Abelino, what's up?
How's it going?
Scared of full stack engineering? Is that what that scream was?
Not at all. Just reacting to the generic Zoom voice when she tells you, "Oh yeah, I'm recording you."
Let's see. Sounds like you've got some cool stuff, and I've got some NAS stuff. Guess you've got networking stuff.
Yeah, some shenanigans on my end.
What do you feel like diving into first? You want to do NAS or you want to do networking?
Let's do NAS. Let's do NAS first. Mine's is pretty brief. It's just a nightmare of a rant of me moving things over.
Gotcha. Cool. Well, yeah. So I got a couple upgrades done to the NAS, and I guess for background, I'm running TrueNAS, and you also run a NAS, but you do it a little differently. So, what for some background? What's your setup look like?
So I have a 1U SuperMicro server running Debian 10, I believe, Buster. And that is just, and I'm running vanilla ZFS off of that, using the native tooling for monitoring. And it's pretty simple. Like, I don't get the fancy dashboard from TrueNAS. I am kind of tempted to, port all that over, but I don't know. I'm not 100% convinced yet. It's a lot of eye candy, sure, but I don't know. I don't see that there's anything I can't do from the CLI.
So you need to embrace your inner IT manager and really want to see those visual metrics instead of the CLI. That's what'll do it for you.
Yeah, perhaps. I am running lightweight Kubernetes, K3S, the product by Rancher, and I've been meaning to install a service there to capture metrics from multiple sources, so from CFS and other services that I'm running through in Kubernetes, but I haven't had the time to set that up. That's the route that I wanted to go in, and have like one big monolith of a service to do the monitoring and the beautifying of those metrics into charts, but I just haven't had the time to set any of that up. And that's the goal, though. That's the goal.
And also, what's going on with your JBOD? Because that's probably going to come into play. And what I'm going to talk about, I'm going to have to set one up myself here. I guess first of all, what is a JBOD?
Yeah, so a JBOD is basically just a bunch of disks, as the acronym stands for. And in my case, I have a 4U appliance made by AIC, and it can handle 60 disks. And it has, everything's redundant on the thing, which is, I just love about it. It has redundant power supplies, redundant SAS controllers, and so it has redundant SAS controller output cards, but the device backplanes themselves have two LSI controller cards per zone, and there's 3 zones. There's essentially 3 huge lanes on the appliance, and each one of those lanes has 2 LSI cards, a primary and a secondary, and then those connect to the output LSI cards, which are just used for transferring out data to a host server, which in my case, the host server is that 1U that I just previously described. And I have a Oh, I don't remember the exact model, but it's an LSI. I think it's a 9300-4E, or is it 8E? 4E is one port, 8E is two ports, right, Alex? If I'm mistaken, if
I
I'm
think
not
that
mistaken.
sounds about right because I think they label them off the PCI bus speed. And if I remember right, I've got an 8E and it's 2 ports.
Ah, yes, then it is 8E. And E stands for external in this case. I do have a 9400 dash 16E, I think, but I opted not to use that because I wanted to use that for another build, which I never got to.
The joys
But
of home lab.
yeah, exactly. That JBOD that I have though is a monstrosity. I believe in the secondary market, so all my gear is used. I bought it mostly from an outlet on eBay called Unix Surplus. I got great deals from them, and this is not a paid promotion or anything like that. It's just that they have some really good offers sometimes. Um, but yeah, I
You should say that again so we can get sponsored. That sounds like a better deal.
LTTstore.com.
That's right.
But yeah, I quickly jumped on that deal because I think it was like $500 for the JBOD unit. I should have bought like 3 more because they're all gone and I can't find the same model anywhere else. And I think retail price for those type of appliances start at a minimum at 5K. But I think I'm pretty sure it's more than 5K. That's the low end that I think they sometimes start at. But like, for example, SuperMicro and the Western Digital appliances that do the same thing, the 4U JBODs, they start at around 14,000 with no drives. And the detail behind those is that you can't buy them with no drives installed. They have to have at least 20% of the base populated. Otherwise, the suppliers will not sell you those chassis, which sucks.
Did they give you the choice between like SATA or SAS, or did they just get you with like those enterprise SAS drives when you're populating it?
That's a good question. That might be an option because on all of these appliances, I've seen that they make the caddies, like the carrier caddies for SATA to SAS. And as you probably already know, most of the backplanes that you'll find on these type of enterprise appliances or data center quality grade appliances, they're all going to be SAS backplanes. But in some instances, the backplane itself is backwards compatible to SATA. In other instances, like in my case, they're not. And I need a caddy that converts SATA to SAS signal, which are probably like $50 a pop, I'm assuming. I haven't actually gotten pricing details on a caddy of those, but that's where my head wants to go in terms of pricing.
So in terms of like ZFS, what led you to using ZFS and kind of by extension, you suckering me into ZFS?
Yeah. So I had a huge monolith of a system. And I think at the time I was running probably like, let's see, 1, 2, 3, 4, 5, 6, 8 drives in software grade using MDADM. And it was a very, very heavy system and a very huge case made by Case Labs, which is no longer alive. Amazing case though, like their products were really good, sturdy, high quality cases. But it was really heavy. And on top of that, the thing was liquid cooled. So that's even heavier when you're considering the liquid plus the radiators. I had 2 radiators of the thing, one dedicated for the CPU loop and the other for the GPUs, because I had more than one on the thing. You can imagine how heavy that thing got. So maintenance on that beast was horrible. So about a year and a half later, I wanted to essentially decompose that monolith and into separate and smaller pieces of infrastructure that I could manage on my network, and it'll just be much easier for me to deal with. And if something goes down, it's not going to affect my workstation, for example. And if my workstation goes down, my storage isn't going to go down, and I could still reach for storage or reach for media on that storage. One other big thing that occurred was the scares with MDADM. Let me see if I can remember the exact details.
So right before you dive into that, so just for like anyone who's not familiar with RAID, for example, what drew you to that? Where did you really get the requirement for RAID from versus just throwing a bunch of disks in the machine and just running like single disks?
So one, I wanted the storage to be just one unit of storage, and not have to deal with the manual mounting of, individual drives into specific directories and all that orchestration. So
you basically got like 8 drives that show up as one really big drive to the computer.
Exactly. And then the next big thing that RAID gives you is parity. You're able to lose, depending on the RAID configuration, 1 or 2 drives, and have those fail over, and also have you replace them until a third one dies. And it gives you the ability to safeguard data, whereas if you were just using single drives, if that drive fails and you don't have any backups, always use backups, because RAID is not the solution for not having backups. So if that one drive fails and you're just mounting it, well, that data is gone. Your best bet at that point is sending it off to a data recovery service, which I hear are getting really, really good.
Still not cheap though, right?
Well, Rossmann out of New York has, I think, a pretty affordable service. It might not be, I haven't used them. I haven't had the that bad of an experience throughout my years with drives to need it, but I hear that they're quite affordable.
Cool. So it sounds like with the fault tolerance and stuff like that, there are still some edge cases and some there's a certain level of fault that you can run into where it still does destroy data, or you still do run into problems. And I think that's what you've been starting to get into before I sidetracked you with that tangent of your not so great experiences with MDADM.
Yeah. I will say though that MDADM is hell of a tool. It's amazing software, and I was able to not lose all my data at the end of the day.
And I guess can't think of the word, but basically MDADM being one software implementation of RAID, and ZFS is kind of another file system that gives you some of those redundancies and resiliencies that you'd get from from a system like that as well. So they're kind of like MDADM and ZFS are kind of comparable in terms of what they give you, but the way that they do it is different.
Yes, and I will say that CFS definitely has more bells and whistles. MDADM is just, your bare bones software RAID. But we can get into the nitty-gritty, the nerdy details in a bit. I don't exactly remember the entire story, but I think I was trying to expand the RAID from maybe 7 drives to 8, and I had a brownout. So the entire system went offline in the middle of resilvering, and I hadn't.
And brownout meaning you lost power to the system while that was happening, and so you didn't have a battery backup or anything like that.
I did not have a battery backup at the time. Now I do. I learned my lesson. And I didn't also, when you're starting the resilvering process, there's an argument in the CLI to create, I don't remember the name of it, but it basically creates sort of like a journaling file with metadata to help MDADM either track progress or track structure of the parity files. I'm not quite sure on the actual science of it all because I never actually looked into it. But that file is very, very important, and it can help out in this scenario where you kind of need the last known state of right before you lost power to help MDADM get back to a good state. I think it's more complicated than that. So not only did I lose power, but the drive was bad.
Oh no.
It was making horrible noises. And it was a brand new SATA Seagate Helios. I think it might have been a 12 terabyte drive. Were those the size of the drives that I sent you, Alex? 12 terabyte?
You sent me 6s.
Okay, then I screwed you over.
Yeah, I didn't think you'd give me the good stuff. I did better than that.
I think there were 12 terabyte drives. I should have probably tested, because of that, I stress test all my new drives now. And I also do it in a semi-quiet room so that I can hear how the drive is operating. Because the audio characteristics that you can, when you're testing the drive, they tell you a lot about, the condition of the drive.
It's like listening for like clicks or the way it's spinning or
yes.
Like what do you...
Yes, if the clicks sound really, really bad, abnormal, something's wrong. Like you don't need to run a smart test to figure that out. So in the middle of resilvering, I noticed that it was making really bad noises that I was not comfortable with. And I was trying to figure out how to essentially stop it or get the RAID array in a degraded state so that it stops resilvering. And that's in the middle of me trying to figure all that out. That's when I lose power to the entire system. I think we lost power for the entire block for a few hours. Once the power came back on, I was scrambling. I was freaking out. I did not want to lose my data. So considering that the RAID array was unmounted, so no service was writing or reading from it while it was resilvering, no new data was being written to any of the drives, right? I think that might have been the saving grace because the parity information was still alive on the other 7 drives. That's by me. I think what I ended up doing was I marked the new drive as bad, and disconnected it and allowed MDADM to try to clean up my mess, essentially do a resilver on the 7 drives that I previously had in a good state. 24 hours later, it finished. I ran, I think on the bigger media files, I have checksums on all the files on in that pool of storage. So I reran those checks on the files and everything was good. So I didn't lose any data and I didn't corrupt any data either. That was just a really, really bad experience for me. It didn't scare me off from MDADM because I still think that it's a good tool and it all depends on the application. It's one of those pick your tools for the right job type of things. But I think this is a good point to segue into why the transition, like why move over from MDADM type of software rate to something a bit more glorious, such as CFS. With software RAID, for example, you're able to expand it by adding more drives to your RAID array, but you also have a limitation as to how many parity drives you can have. And you could expand it to X amount of drives from my understanding. And if you started with a RAID 5, you're only going to have one parity drive for like 10 or 18 drives that you decide on. And that's no good.
So that means if you've got like your 60-bay JBOD and you're trying to run MDADM RAID 5, then you have 59 drives that are storing your data and one parity drive for your parity data, and you can lose at most one drive in that 60-bay unit. And as soon as you lose the second drive, you've lost all of your data on that 60 drive unit. So you need, now granted, of course, there's other levels of RAID. So you've got like RAID 6 where you can have 2 drives of parity, but basically those weren't going to be enough for the volume of drives that you were running, right?
Mm-hmm. Yeah, exactly. So then I started doing some research and I came across CFS and started hearing really good things about it. And CFS, it's not only software RAID, it's a file system, and it also has additional services that you can enable, like Samba, for example, or NFS. I believe it also has NFS. Don't quote me on that.
I can say TrueNAS does, so I can quote that. So I know like TrueNAS will expose. So for file sharing, you can do Samba, you can do NFS, as well as iSCSI. So like I'm using Samba and iSCSI, and I think I don't have any Apple devices, but I think they also have like some Apple Share or whatever Apple's thing is. They do that.
Netatalk or something like that.
I feel like that's an older one. Anyway, I don't know. I don't know my Apple stuff, but I saw they do some kind of Apple sharing thing in there. So yeah. So basically, it can support a wide array of devices.
Mm-hmm.
There's a ZFS pun in there if you picked up on that. So
yeah, and I didn't pick up on it immediately, but thank you for pointing that out. So my next set of requirements were I wanted to keep redundancy across all drives. or increase redundancy actually, because I think at the time I was running that MBADM array in RAID 5. So that's one parity on the 7 or 8 drives that I had installed. I wanted to move away from that, and also wanted to have the flexibility of adding as many drives as I wanted to. There's a catch to that for sure, and we'll get into that in a bit. But CFS solved all of that for me. And it also, as I was POCing it with some SSDs, it was very easy to set up, extremely easy. And I didn't need to muck with the file system layer in Linux to set up the file system, because CFS does that for you. So I opened up eBay and started getting into researching hardware, and I really wanted a 4U chassis with top loading drives, essentially, where I could just pull out the chassis, take out the lid, and just plop in drives or pull them out from the top. The other variant.
You still have the manual while you're talking about that, because it'd be cool to see like a visual of it while you're describing it, because from what you showed me, it was a really cool unit.
Yeah, I need to sneeze, so I'm gonna mute myself.
Just do it.
Okay, let me look it up. For you, 60. And yeah, I think it'll be a good idea to screenshot that. Oh, I just remembered also that one of the internal SAS cards was bad when I got the unit. I don't know if you remember. When I first would start trying to set CFS up, I kept getting the pool kept going into a degraded state with all new drives.
Oh yeah, I remember you having that problem.
That was fun to debug.
Did they? I feel like they ended up fixing. Did they fix that for you, or did you have to buy another card?
No, they shipped me out a new card.
Okay.
Well, Unix surplus, since they had many of these in stock at the time, I think they just pulled out one from one of the other JBODs and shipped that out to me.
Was this related to one of the problems you were having with like either password protected firmware or like the right revision of firmware on the card or something like that? Or am I thinking of a different problem?
Two different things. One of the LSI cards was flashed with an incorrect version of the firmware. And on top of that, the way they set a value in NVRAM was incorrect, because the value needed to be like the serial number that's on the card itself.
That's what I was thinking of.
It was like this completely different number. So bad, but I did fix that one, and I got that one up and running. And the eBay seller gave me a huge discount because I went through all that trouble.
Oh, cool.
All right, I found it. Let me move it to the window. Let me share my screen here.
Yeah, because I'm sure for anybody who hasn't worked with a rack-mounted unit or seen the insides of one of these, probably helps to see the picture and what you're actually working with this.
Yeah. So this is a beast of a unit. This is what it looks like from the front. When one of the drives goes bad or is is marked as failing, one of the red lights will come on depending on the lane that the drive that failed is in, which is nice.
And so you've got 3 red lights down there, it looks like, for each of the lanes.
Mm-hmm.
Okay. And then green for power on the side. Is that what all those lights do?
Yeah, there's one warning light for in case there's fan failures. There's another one for overheating, and then there's another one for power failure, like one of the PSUs died or something.
Yeah, so that's another good point. So this actually has redundant power supplies in it as well. So
yes, I definitely learned my lesson, and everything in my home lab is now redundant. Except my power supply. I need 2 of those. I just have 1. Or I should get an extender. That's what I need.
There you go.
So this is the rear. I modded the fans because they were really, really loud. And I bought, I believe, same model, same brand, but just less RPMs, and I think half the decibel noise value, which definitely lowered the noise that they emit by like half, I think.
So what you're saying is we're not getting the Noctua sponsorship anytime soon.
No, we're not. Noctua cannot. This entire chassis would fry with Noctua fans.
Not enough airflow.
So another appealing thing is that this has 1400 watt PSUs, whereas other units from like SuperMicro and Western Digital will have 1600 watts. So you'll definitely need to use a different sort of outlet for that with more amperage.
Meaning you need the 20 amp power connectors with the slanted prong on them rather than the standard 15 amp connectors.
Exactly. Mm-hmm. And these are right here below that. Can you guys see my cursor?
Yeah.
Oh,
yeah,
okay,
it showed up.
Cool. Okay, cool. So the top card is the secondary LSI card, host bus adapter, HBA card for connecting to your host system that will be reading these devices. And then the one at the bottom is the primary. The last slot is IPMI. So for external management of the units, and there's 2 ways to manage it. One via a sort of FTDI cable on the right-hand side, and then Ethernet. So you'll be able to get to the unit via like a web UI. It's on a different subnet, and I still haven't fully worked out the kinks, so I can't show you what that looks like just yet.
No problem. And so with the with those 2 cards you showed in there too, so like if I look at this from like I've never seen a rack mounted like appliance before. This looks a lot like a computer. It looks a lot like a server. But you mentioned the term, these cards connect to the host. So kind of just to clarify around that, like this thing, and hopefully there's a picture of like the insides of it.
Yeah,
but
I'll download the manual in a bit.
Yeah, that'd be cool. But there's no processor in this. There's no computer in this. It's just a bunch of disks that basically get fed through some controller cards out to these ports. But then they actually need to go into a server, into some kind of computer to be able to use the data on this. So like this whole storage enclosure is really just one big glorified disk drive.
Yeah. So this might look a little bit familiar for those in the audience that watch LTP and have seen his Storinator videos. So the Storinator is also a 4U chassis that can store 35 drives, and I think the extended one is maybe like 60 or 120 drives. I don't remember the quantity there, but those chassis require it's a whole computer. So it requires not only the stuff to connect all the drives and all the hardware required for reading and connecting the drives, but also a motherboard, a power supply, and everything else to be able to run a full operating system. And I believe on the Storinator, they ran Windows. I don't understand why, but that's their choice of operating system because it's easy. And I do know that the Storinator comes with a redundant power supply variant, so that is kind of nice. But to me, that felt a little bit dirty. Like I didn't want to go the Storinator route because I wanted to decompose my systems a little bit further. I wanted something that just dealt with storage, and then I wanted another system adjacent to it that would be controlling that would be reading those drives as if they were connected directly to that other server, but they weren't actually physically in that server. And that's why I mentioned earlier, like I have a 1U server like that is dealing with all this storage. And then I have this monstrosity 4U that has, I don't know why I opened it. I wanted to take a drink, but I didn't. And yeah, this is a JBOD. It's just a bunch of disks. We're going to get into the internals, which hopefully will make things a little bit more clear. But to sum things up, there is no motherboard on this thing. It's essentially just a big box with a lot of drives that you then hook these ports to your computer via an HBA card, host bus adapter. And then your computer sees whatever is connected inside of these, whatever drives are installed inside of this appliance, as if they were directly connected to your system, because they are, but through a PCI card, typically known as a host bus adapter.
And so for like in the reverse case of this, where if somebody didn't want to separate those units out and they just kind of wanted the all-in-one solution, like you just buy one box, you can put a bunch of drives in it and throw it in a rack, and it hosts your storage across your network to all your other computers and stuff you may be running. Would the Storinator be a good one of the good potential options in that case?
Yeah, totally. Like if that's all that you want, you just want just one for you, and that's all that's going to be in your rack or whatever, or you're just going to have a bunch of those and network them together. That's perfectly fine for that use case.
So the trade-off you probably didn't mention there would be the separating out the units, although you get more control over each unit and you can kind of spec out each unit to the way you want it. Is probably going to come at a higher price tag because now you're dealing with separate units that you have to wire together rather than the all-in-one solution, right?
Yeah, I definitely did not touch on that. And yes, you're right. So if you go with a Storinator, you have to buy a motherboard, a CPU, memory for all those, an SSD to run the operating system on for that one Storinator. You have to do that for all of them. So by just having like one additional server on top of the JBOD, you're reducing that cost by like 2x essentially, because I don't need to buy 3 motherboards or 3 power supplies, 3 memory kits to be able to run the storage on my network, or at least to expose the storage on my network.
The opposite though would be like if you're only going to run one system, like you only need one that has 40 drives or whatever. Right. For a single system, you're going to be paying more for the separate components, right?
Yes. That is 100% true. And ultimately, it really comes down to like how much you're going to scale. Like, how much do you see yourself needing in the next few years? And while I don't think I'm going to fill up all 60 bays anytime soon, I personally wanted to decompose it because I wanted the original plan. And I'll touch a little bit into that here because I have the nice diagram here. But the original plan was to allocate portions of the JBOD to multiple servers. But I haven't bought the other servers, and I never ended up doing that anyway. So it's just one big storage pool right now. And the cool thing about the LSI cards that we have in the rear is that we can assign zones in our JBOD to essentially be accessible via specific ports here. So I could say like this lane here is accessible via port 1 and 2. The middle lane can be accessed via 3 and 4. And then the other third lane can be accessed by the last 2 ports, so on and so forth.
So can you zoom into that diagram down there and explain what's going on? Because it's kind of hard to, it's hard to tell what's up down there when it's zoomed out.
Yeah, so let me see. I know there's another, here we go. This is the one that I wanted. So, like I said earlier, this chassis has 3 backplanes. And there's the center edge, the center backplane, left and right. And each one of those lanes has a primary and secondary LSI card controller. And they're shoved right here. So, and the cool thing about that is that you could actually go in while the thing is powered on and fully functioning and just get rid of one. And the thing will continue to function. That's the beauty of having redundant controllers. Because if one goes bad, you could just go in there, replace it. It's going to be functioning perfectly. And, plop in the new one, and the controlling server would never have known that you went in there and replaced something. So as I mentioned earlier, I could assign essentially like the left edge zone and all these drives that would populate in this backplane to a specific port. And then that means that I could then connect those 2 ports, for example, into a specific server, and only that server can access the hard drives on the left zone, for example. That was my plan. I wanted to have 3 servers and then just essentially carve out left, center, and right to dedicate those zones directly to each one of those servers. But I ended up not even doing that, and I'm probably not going to do that. That's a different story, but that is a possibility. There's another way of doing things, and that is to allocate. To split the entire chassis into 2 discrete zones. For example, it'll be the first 2 lanes. So this one and this one, that's one zone. And then this is the second zone. And you can also allocate those zones to a particular connection in the rear. And I think in terms of configuration of zones, it's limited. I think there's one big zone, there's 2, and I think there's only 3. I think that's the max number. Don't quote me on that. I could be wrong there, but it's limited in terms of how many zones you can configure this thing. And as you can see, now that we're kind of in here, like there's no motherboard. This area is empty. If I would plop the top case open, like this is empty. Like these are The controller cards, some of the LSI controller cards are here, and then there's two somewhere here. Yeah, there's two here.
And then back down there, like around those controller cards in the front to like the back middle portion, all those are the hard drive slide. They slide in from the top down. Is that right?
Top, yeah. Yeah, and the other configuration, the other type of this isn't actually fair because SuperMicro actually has a top-loading chassis, but this is the other variant of a 4U that is also a JBOD. It's usually they have them front and rear loading, but I fell in love with the top-loading appliance, and I was adamant about buying one like that.
So what drew you to the top loading? Because my JBOD is like, so I have a SuperMicro JBOD. It's not online yet. That's something that we'll end up talking about on how to get it online because it needs a couple parts. But I've basically got the baby version of this that has 12 front-loading bays. So, and I found the front-loading to be really convenient, but I also just had to swap a bunch of drives this weekend. So, so what drew you to the top loading, where you essentially have to pull the unit out of the rack and then take the case off to get to it, rather than doing the front loading where you can pull the drives without basically pulling the entire chassis out?
Yeah. So space, like the same amount of space that it takes for this JBOD to house, what is this, 45 drives. The other one has the ability to house 60. That was just, that's where it was like for me, like, oh, if I want more, then I'm gonna need 2 of these, and I'm gonna have 90 instead of, I could have had 120, for example, if I had 2 of the other appliances. But like I said, SuperMicro also has top loading, so
yeah. And is your how full is your JBOD? Did you fill it up yet, or what percentage have you reached?
I think I have the first 2 rows full, and then plus 2.
Okay. So if I'm looking at your little numbering chart over there, it looks like maybe 32 drives.
Maybe. Yes, 32.
Okay.
So barely, a little bit past halfway. And this goes into the zones here. So zone count 2, and it splits it up this way. 4 splits it up that way in terms of rows. And they all get their dedicated port there. Oh, I thought we were able to do also in vertical lanes, but I guess not. I guess I was wrong there. So it's 1 big zone, 2 big zones, or 4 split up in the dedicated rows.
Gotcha. And so if you zoned it like that, that's what would let you partition your JBOD there to where essentially more than one server could access it, since they can't. Yeah, since the servers can't share the disks at the same time.
Yeah, exactly.
So what's your new strategy for getting the data off of these then? Is this driving strictly a NAS that's going to expose the storage over the network to the other servers that you have, or what are you thinking there?
What do you mean?
So like you mentioned that you aren't actually going to partition this off into groups and have the other servers that you've got directly use the storage. So are you thinking like this is going to be network storage for those to access it, or like?
Yeah, that and cold storage. I have another appliance for SSDs that is still not up and running. But I wanted to use that more for like general storage, and use it in conjunction with another of the Rancher Kubernetes products for ephemeral storage for containers. But I haven't had the budget to actually go out and buy, 10 or so SSDs.
Mhm.
But yeah, that's one of the plans. And this is more for like media, backups of whatever we have here in the house. And that's pretty much it. Anything that is important, at least work-wise or whatever, it's up in repositories and or backed up in S3. I've been using Keybase a whole lot for personal projects. So like, for example, I don't even have my personal projects backed up on my storage unit here. They're all, in Keybase encrypted.
Mhm. And so you mentioned servers running Kubernetes earlier. And if I remember it, I think you actually run K3S.
Mm-hmm.
And so like those are those essentially going to use the SSD storage when that's up and running, and like this is not going to be a factor in that, or like what are your thoughts there?
There are some services that read off of the storage for like, for example, Plex to stream any of the video content locally to whoever's on the local network. So there's some of the services are still going to need read and write access to the storage, but for general purpose storage and maybe ephemeral storage, I'm probably going to be using the SSD because at the moment the 1U has just one Samsung. What was it, 670 or something SSD, a pretty good SSD from its time, but one, it's not backed up, and two, that's all it's using for the containers at the moment for storage, and everything else like configuration and media is stored on the JBOD in CFS. I should stop saying on the JBOD. I should say CFS.
Funny you mentioned the SSDs and Kubernetes and stuff, because that starts running into
it's a perfect segue, right?
Some of my challenges, yes.
Let me see if there's anything more interesting in here. Oh, like this is what the backlinks look like.
And so go back up to that real quick. So for anyone that's not familiar with what a backplane is, like what's that actually doing?
It's a big board. I don't want to call it a motherboard because it's not, but it's a big board with a bunch of connectors to one specific application. That's typically what a backplane is. And in this case, the ports are all SAS3 connectors, and we have 3 here. The one thing that I almost screwed up when I first bought this thing and I was messing with it, the SAS cards that we saw in the center of the JBOD are actually connected to these backplanes. So while the SAS cards are installed, you can't pull out the backplane. I probably should have read the manual. I didn't damage it at all, but it's something that can potentially happen. Some other chassis have the SAS cards installed in a different location that does not allow for this confusion to occur. But in this case, it wasn't in the stars here.
So all you need to remember for this scenario is the equation F plus I equals R. That's the formula that solves this problem. You know that one?
No, but please explain.
Force plus ignorance equals results.
Oh, God.
So if you just apply enough force, you'll get some results.
Yeah, exactly. So here we see the LSI cards. And the backplanes obviously expand beyond that because we have more drives after the LSI cards, right? And the drives connect directly to the backplane. So with that logic, that means that the backplane ends somewhere around here. And if this is connected, well, you can't pull it out.
So the backplane is essentially a giant port splitter.
Yeah.
So that the controller card has what, like two ports on it or something like that that come out of it to be able to
I think it also has 4.
Okay.
They have a good diagram of the actual card.
So the problem being, you couldn't necessarily come directly out of that card. You could get then like, you could break it out to like 4 drives if you just went 1-to-1, but the card itself doesn't have, the controller card doesn't have enough physical connections to be able to connect 20 drives or whatever it connects to here, right? So that backplane is taking those, say, 4 ports out of the controller card and splitting them up into 20 ports that each one of those drives can plug into in one of those lanes.
Yeah, from my understanding, and my understanding is limited here because I haven't actually done a whole lot of research into how the LSI cards actually interface to the devices themselves, but the LSI controllers, they have the ability to control up to 1,024 hard drives on one controller, on one chip. That is freaking amazing.
Yeah.
In this case, two chips even is overkill for the amount of devices it's going to be controlling. Like, it's nothing. These are a bit toasty though, so they do get warmed.
Well, there's a flip side to that, right? Because if you've got a single, well, let's say you've got a single port coming out of that, yes, the controller might be able to address 1,000 drives, but can that one single port, or in this case like 4 ports, but we'll just call it 1 port, can it actually support that much bandwidth for all of those drives to be reading or writing at the same time? Yeah, and so that could be another one of those advantages to where, like, that's a good benefit here of having those 3 backplanes in there, is now you've kind of got your system split up across essentially like 3 controller cards, or 6 if you include the primaries plus secondaries. So you're kind of like expanding the size of that pipe as well. So like, you're not just worried about like controller failure and redundancy in that case, but you can actually push more data through the system by doing that as well.
Yeah, and these appliances, they're built for that. Like they're built for throughput and efficiency. So if you definitely have, like, for example, if you populated these whole things with SSDs, and maybe get more reads and writes than you could get from like a spinning Rust, I think the chassis can actually push all that data through. Now, the limitations actually happen at the other end, depending on your configuration. Because if we go back to, lovely, right here. If we go back here and we just have, let's say we configured the JBOD to just be one big zone, right? That means that the first port is going to be assigned to the one zone, and you're only going to be reading. You're going to be reading from all those drives potentially just from one connection, from one mini SAS HD connection. And I don't remember what the bandwidth on that was, but you also have to consider that on the other end of this, you're connecting to an HBA card. And I haven't seen an HBA card that is X16, meaning it's going to utilize the entire bandwidth of a X16 PCI slot. I've only seen them in X8, and I think you have also seen that, right, Alex?
From what I remember, yes.
Yeah, and that means that if you're trying to read from one big zone through one single pipe through an X8 HBA card, you're going to hit a bottleneck there. And, depending on your application, that might be just fine. But, for us nerds that want maximum power, we want to be able to maybe push that a little bit further. And the way to do that is to split the JBOD into the maximum amount of zones, have 4 HBA cards, 4 HBA cables coming out of this, and connect it to 4 HBA cards to your main server. And then you have essentially one, did I say 4? Was it 3 or 4? Oh yeah, it was 4. It was 4. That was the maximum of zones. And by having that configuration, you'll be able to maximize throughput between the JBOD and your storage server. And that's ultimately my goal. But as you remember from earlier, I said I had a 1U. I can't possibly fit 4 HBA cards in that 1U.
Well, I think if you use that liquid PCI switch, you probably could, right? So you've just got some more rack gear to install there.
Yeah. Have cables dangling off the chassis.
Yeah. That's in true home lab spirit right there.
Yeah. I think that's ultimately my goal, to be able to do that, but that definitely means upgrading to at least a 3U, or a 2U might be able to do. Yeah, a 2U with enough PCI slots might also be able to do that, because the HBA cards, at least the ones that I have from Broadcom, they're 2U compatible. Like, the height of the cards are actually not that bad.
Mm-hmm. Yeah, and I guess, so if you were doing this as the NAS setup and you're not as worried about getting these lanes directly out to each of the servers, let's see, if I remember right, you've got three 1U servers, right, that are clustered together?
1 1U server. The goal was to eventually get 3, but I never did it.
Oh.
I actually have
okay. Well,
2 2Us right here, but I haven't actually got them up and running. They're actually also SuperMicro 2Us. Okay,
gotcha. Because you're probably on to what I was thinking then. Because those 2U SuperMicros do make really good NAS appliances. And so if you throw one of those in, and then I was thinking you had the 3 1Us clustered.
No.
But
that was the plan. We talked about it a while back, because there's 1Us on eBay where, like, there was something stupid. They were like maybe $300 a pop. And they came with some memory and CPUs already installed, redundant power supply and all that nice stuff. But I never actually pulled the trigger on those because I think what was overruling me was maybe I should get a 2U so that I could beef up the storage server, and then I'll worry about adding more 1Us to the Kubernetes cluster.
Mm-hmm. Then you probably got chip shortage on those, huh?
Yeah.
Do they still exist? Yeah.
Actually, no, that's a good question. I don't know if they actually exist. I'll have to look them up.
But yeah, so that's probably a cool way to do it then, because those 1Us, if you don't have to worry about stuffing those full of controller cards, you could put like a 4 by 10 gigabit NIC in there. And if you threw that in, you've essentially got like 40 gigabits of network coming out of each of those. I was about to say, yes, that's going to be slower than the SAS controller, but that might actually be a bit of a lie. You can do a lot. You can do a lot with 10 gigabit with a 10 gigabit pipe that's dedicated to storage, which is what I'm doing right now. Because you still get you still got a higher bandwidth than you do with SATA. So like SATA to a drive is 6 gigabits. So if you're running 10 gigabit Ethernet, like, you've got a bigger pipe right there. So then if you've got a bigger NIC and you've got, like, 4 by 10, for example, granted, you don't actually get a true 40 gigabit pipe just by plugging in all the cables. You actually do have to do round robin packaging and some other special setup stuff. But we'll just say in theory, you've got 40 gigabits coming out of that. Like you've actually got a pretty good pipe. And you can get that in essentially one card slot.
Mm-hmm.
So that wouldn't be too bad of a solution for storage. And I'm guessing what you're probably running on those workloads with the Kubernetes stuff is like, you're going to hit the disk for like when new containers spin up probably to like get the images and stuff like that. But the other cool way with how Kubernetes works is it's going to spin up your new containers before it tears the old ones down. So like you're not in as much of a rush to get those containers spun up. I mean, like in theory you are, but in practice, like your application isn't going down during that time. So it sounds like a pretty cool setup.
Mm-hmm. Yeah, and another reason or another thing that I wanted to try out with the 1U servers was Proxmox. That's another thing I wanted to try out, but I haven't actually gotten around to playing with that.
That would be cool. And what is Proxmox real quick for folks who haven't heard of it?
It's a virtualization hypervisor, if I'm not mistaken. It also has the ability to be redundant, and that's where the other 1Us come into play, so that you can have redundant virtualization, redundant VMs, and if one server goes down, you still have two other nodes to support you.
Mm-hmm. So in your current system, you're running Kubernetes, or basically the lightweight Kubernetes K3S,
mm-hmm.
and that's letting you spin up containers across a cluster, whereas Proxmox will let you spin up virtual machines, full VMs across that cluster. Yeah. This is actually a great probably spot for a break, and then we can come back and dive into I guess my virtualization solution, or it's not virtualization, storage solution / problems.